Hello again, viewers. COVID-19 may have stopped school, but there's nothing that can stop learning. That's why, with the amount of time I have available, I'm going to use this opportunity to show you my note-taking skills that I use in math. Now you may say this subject is entirely irrelevant, with so many people being out of school and the algorithm not even bothering to touch this video provides no actual utility. Okay, to start off with, there's a lot of ways we can take notes. Some do point by point, others write descriptions, and others create arrows to such a degree that your paper ends up looking like a Jackson Pollock painting. How do I know this? Well, I was that person. Avoiding the work of writing sentences and the confusion of points and arrows, I'm proposing highlighters to be the best tool for taking notes. By using highlighters, you achieve 3 goals: efficiency, the ability to describe structures, and to provide references. Structural description means understanding the logistics of an equation, understanding what types of terms there are, and how do they relate. I'll explain it further in this video. Providing references is having the ability to look over your equations and to understand the patterns that you find, and most importantly, finding out how you got to your concluding answer, so you no longer have to throw away your notebook at the end of the school year. Okay, for this demonstration, I'm going to show you a quick little tip that you can use in case you want to do more efficient highlighting. So do something just take a piece and just something like this. So now you don't have to worry about all your markers being picked up everywhere. I call this the Tri Highlighter 1.0, designed by me, that's trademarked by the way, and patented. And then you start reading. As a point of clarification, we're going to avoid mostly single-term equations due to their simplicity and immediate answers. Rather, let's use this equation. 15 plus 4x plus 10 minus 3x equals 5x plus 6 plus 3x minus 2. In case you don't know, start by highlighting like terms. After, try and get x by itself, all the while color-coding your answers till you reach your final answer. By the end, you will have a formula showing similarities on what to convert or move, and having a final answer keeping consistent colors to show how you got to your final conclusion. Now we have notes that not only show steps, but provide us a roadmap to how we got to our final answer. Well, to be honest, I think we can take this up a notch. Alright, so let's try and find the area of this wall and these 2 windows. Quite self-explanatory. By now, highlight the area of the wall, followed by the windows, giving you an area of 124 and 24. Quite easy now, right? Well, let me now throw you a curveball. How about polynomial equation? 3 multiplied by 4a minus 3c multiplied by 5a minus 2c. Before anything, distribute the 3 to the first 2 terms. With the first 2 terms multiplied and color-coded, start by distributing those to the next 2, 5a minus 2c, giving you 60a squared and negative 24ac from 12a, and 45ac and 18c squared from negative 9c. Once again, color code each term as you go along and combine them accordingly. If you already colored them and need to color them again, use additional line to show that you are combining terms that aren't confined to the current colored terms. And there you have it. You now have a purpose to look back at your notebook without needing to feel confused. As I said, this strategy I found to be universally effective when giving math questions, be it a word problem, to graphing, to volume calculation. Once you get into this mode of note-taking, you'll start to identify patterns which are a major feature that is overlooked, not just on paper, but in our everyday lives. You could say that our lives are organized by patterns, great or small, universal or specific, long or short term. For it's these rhythms in life that we live by that determine our future. And if we do take the time to learn from them, we are more likely to avoid and fix future errors.